Hey guys, it's Miss Bettis. So I'm going to go ahead and start doing your test review for number 8, or test number 8. Your test is going to be this Wednesday, which is January 29th. And if for whatever reason there's no school, you get to take the test the next day. Yay, you. So no surprises there. I'm going to do the first part, the first 11 problems, and then Ms. Pasquale is going to upload her video, and it'll be the last, I'll do the first 11 and she'll do the last 11. So let's go ahead and get started. So number 1, a line is represented by the equation y equals 6x plus b. Notice that they put a b there, not a number. We know that is going to be our y-intercept. And they're saying that b is going to be a positive number. How will the graph change if the value of b is decreased by 3 units? So we know anytime we make changes to the y-intercept, it's going to move the graph either up or down. So let's look at these answer choices. A says the line will be shifted to the right. Well, automatically we can cross that out because we don't move the graph right to left. B says the line will shift to the left 3 units. That can't be it either. The line will shift down 3 units. Well, we know we are decreasing, so decreasing does mean it's going to go down. So far that looks like the correct answer. And the last one says the line will be shifted up 3 units. Well, no, we're going down because it's decreased. So the correct answer is C. Let's look at number 2. So, number 2 says the equation y equals 3x is shown on the graph below. Right here. Notice how the y-intercept is 0 and it goes through the origin. Which is most likely the graph of y equals 3x plus 2. So our slopes are the same. The only difference is that plus 2, which is our y-intercept. Now, we're going to be moving our y-intercept up since it is a plus 2. Now, if you look at F, it says our y-intercept is going through the origin, which is 0, 0. That's not right. It needs to be going through positive 2. We look at H, and the y-intercept is a positive 2. So far that looks good. We look at G, which has the y-intercept at positive 2 also. So we're going to have to go back and look at those two again. And J has it at negative 2, which is wrong. It should be a positive 2. So what's the difference between these two? Well, here we see that the slope is going down from left to right. So our slope is negative. And for H, it's going up from left to right. So we know our slope is positive. Well, if we look at our slope, we see that our slope is a positive 3. So our correct answer is H. Alright, so now let's look at number 3. So number 3 says to find the slope of the line and the y-intercept, and then write the equation. So let's start with the y-intercept. We see that this graph crosses the y-axis at a positive 1. So I'm going to put plus 1 right there. Now we're going to look at the slope. Now we know whenever we're finding slope from a graph, we talk about like Call of Duty and those type of video games. You want a point that's going to be right at the crosshair, meaning right here, like that little cross point. We don't want a point like this one right here because it's in between, and that's going to give us a decimal or fraction. We don't want that. So we keep moving, and we see there's another point right there. So now we need to count how many boxes down and to the right that we went. We went down 1, so it's going to be negative 1, and over 2. So our slope is negative 1 over 2. So now let's write our equation. We know we're going to have a y equals mx plus b, where m is our slope, so it's negative 1/2, followed by the x, and then our y-intercept, which is plus 1. So that's your equation. Number 4. Write an equation in slope-intercept form, y equals mx plus b, that passes through the given points. So the line's going to pass through 1, 4. So let's make that 1 the x1 and that 4 the y1. negative 7, comma 8. So it's going to be our x2 and y2. So we're going to plug those points into our formula. Y minus y1 is equal to m x minus x1. So we're going to replace the y's and the x's with the points that they gave us. So that's going to be y2 is 8 minus 4 from here and right here. We don't have the slope, so we're going to leave that as an n. Our x2 is negative 7 minus our x1, which is 1. And let's go ahead and reduce this. We're going to have 4 is equal to m over negative 8. Now I need the m by itself. I need to solve for the slope. I'm going to divide each side by negative 8 to get the m by itself. And when I do that, I'll get 4 over 8, and that's a negative, which can be reduced to negative 1/2. Alright, now that I have my slope, and it's reduced, I'm going to go ahead and plug that into my y equals mx plus b, my slope-intercept form. I'm going to plug in my slope first, which is negative 1/2. And I get to pick whichever point I want for my y and my x. I'm going to go ahead and pick this point right here, only because both numbers are positive, and it's easier to work with positive numbers. So the 4 goes for the y, and my x is going to be the 1. We don't know the y-intercept, so I'm going to leave that as plus b. Well, let's start reducing and simplifying everything. So negative 1/2 times 1, well, that's just negative 1/2. The 4 comes down. I'm going to add the 1/2 to both sides. And when I do that, I will get 4.5. So all I did was add it to each other. So now from here, I have my slope and I have my y-intercept. So the last thing I need to do is combine it. So I will have y equals my m, which is negative 1/2, my x, and then my b, which is 4.5. So there's our final answer. I know it was a lot of work, but it's okay. There's only going to be a couple of problems like that on your test. Alright, so now let's look at number 5. It says a hot air balloon's altitude in feet during its descent, so we know it's going to be going down, for landing can be found using the function f of x is equal to negative 40x plus 400, where x represents the horizontal distance in miles from where the plane begins its descent. Another hot air balloon's altitude can be modeled by this function right here. G of x is equal to negative 40x plus 450. Which statement best describes the difference in the two hot air balloons? So let's look at these two equations real quick. We see that the slopes are the same, the negative 40s, and we see that the y-intercepts are different. The first hot air balloon starting at 400. Where the other one starts at 450. So let's look at these answer choices. The second hot air balloon starts its descent from 50 feet higher. Well, is the second one 50 feet higher? Yes, so far that looks good. A second hot air balloon starts its descent from 50 feet lower. No. We see that the second one, it is a bigger number, so it's going to be higher. The second hot air balloon descends 50 feet per horizontal mile faster. Well, anytime we see the words per, we know that's going to be our rate, which is our slope, and those did not change at all. So we can automatically cross out C and D. So our correct answer was A. Alright, let's look at number 6. The graph of the line M represents y equals negative 1/3 x minus 6. The slope of the line M is multiplied by negative 10 to create line W. Which statement about the graph of the two lines is true? Well, let's find out what line W's equation is. We know we're going to multiply our slope by negative 10, and our slope was negative 1/3. So if I multiply negative 1/3 by negative 10, I'm going to end up with a positive, 2 negatives gives me a positive, 3 1/3, or 3.333 repeating. So that's my new slope. So that equation is going to be y is equal to 3 1/3, since it's the slope, the x comes after it. And we didn't change that y-intercept, so we're going to leave that minus 6 the same. So now let's look at it. Line W intersects with line M. Well, we notice that the slopes are different, so it's not parallel, which is what answer choice B says. If our slopes were the same, then it would be parallel. So it's not B. And if it's not parallel, it is going to intersect at some point. So far that's true. C says the line W is 10 units above line M. Well, if we look at our y-intercepts, they're going to cross right there, negative 6 and negative 6. So we can't say that the whole graph is 10 units moved up because our y-intercepts are the same. And we can't say it's 10 units below because our y-intercepts are the same. So the correct answer is A. And if you ever get stuck, you can always graph it on your calculator. You'd put this equation and the original equation into your y equals and graph it and see if these are true or not. Alright, let's look at number 7. Number 7 says, how does the graph of y equals 1/4 x compare to the graph of y equals negative 1/4 x? Well, if we remember, hopefully, that our slopes, when we're comparing steepness, which is what A, B, and D are talking about, we don't care if it's positive or negative. The only thing the positive or negative does is change the direction. So if we just look at the absolute value of your slope, meaning if it's negative, it's positive, and if it's positive, it stays positive, we're going to have the same slope, 1/4 for both equations. Meaning it's not going to be steeper or less steep, but they're going to have the same steepness. And answer choice C said that if y equals 1/4x is higher on the y-axis. Well, both of our y-intercepts are 0, so that can't be true. So D is our correct answer. Number 8. How does the graph y equals 2x plus 2 compare to the linear parent function? Well, that's something you need to know. The equation of the linear parent function is y equals x. Oops, sorry. So y equals x. So to go from y equals x, let me rewrite that for y'all. Y equals x. To go from the original linear parent function to this one, we needed to add 2 to the y-intercept. So it's going to be higher. So we can cross out A and C. And going from a slope of 1 to 2, did it get steeper or less steep? Well, if you said steeper, you are correct. So the correct answer for number 8 is B. Number 9. What is the equation of a graph if y equals 3/4x minus 7 is shifted 5 units up? Well, if we're going to go 5 units up, we know that we're going to start changing the y-intercept. So if we're going from negative 7 and we add 5 to that, we're not changing our slope, so that'll stay the same, 3/4x. And we add 5 to negative 7, our new y-intercept will be negative 2. Now they want us to graph it. So if I start at the origin and I go down 2, I'll be right there. our slope is positive, so I'm going to go up 3 and over 4. And put the dot there. And then I'm going to repeat that pattern until I don't have any more room. And when I can't go that way anymore, I'm going to go to the other side. 1, 2, 3. 1, 2, 3, 4. So I'm going to connect those. And I'm done. Alright. Almost done. Number 10. A plumber charges an initial fee of $100 plus an hourly rate of $50 to repair. Well, we know that's going to be our slope, and that's our y-intercept. To repair leaky faucets. If the plumber changes his initial fee, initial meaning our y-intercept, to $120, how would this affect the graph of the linear relationship? Well, we're not changing the rate, so it's not going to become steeper or flatter, so we can cross out A and B. We're only changing the initial amount, which is our y-intercept. If we started off with $100 and now we're charging a base fee of $120, it's going to increase, not decrease. So the correct answer is C. Alright, last one. The graph of the function f of x equals negative 3 over 2x is shown. If the line is translated 2 units up and its slope has an opposite sign, meaning if it's negative it's now positive, write the equation in slope-intercept form of the new line. Alright, well, we know our slope is going to just change signs, so instead of negative it's going to be positive 3 over 2. And we're going to move this whole graph 2 units up. So the y-intercept was 0. If I go up 2, I'm now at positive 2. So that's where I'm going to stop, and Miss Pascal is going to pick up, and her video will be posted. Just look underneath the comments, and then the link will be right there.